plus 1 by root 2 plus 1 by root 3 plus and so on 1 by root n minus 2 root n minus 1. So then like which of the following statements are correct? So first, like if we consider xn is summation k is equals to 1 to n 1 by square root of k minus 2 into root n minus 1. So if we compute the increment, so that is xn plus 1 minus xn, so that is nothing but 1 by square root of n plus 1 minus 2 into root of n plus 1 minus the square root of n. So that means this is nothing but 1 by square root of n plus 1 minus 2 by square root of n plus 1 plus square root of n. So if we compute this value, square root of n plus 1 plus n minus 2 root n plus 1 by square root of n plus 1 into square root of n plus 1 plus root n. So that is nothing but root n minus root n plus 1 by root of n plus 1 into root n plus 1 plus root n, so which is less than 0. So that means xn plus 1 is always less than xn. So that means this sequence xn is strictly decreasing. So we can see that option B is correct. Now like if we consider regarding the boundedness, so here like we're having, so if we consider the function f of x as x to the power minus 1 by 2, so that means this integral 1 to n plus 1 x to the power minus 1 by 2 dx is always in between k is equals to 1 to n 1 by square root of k is always less than 1 plus integral 1 to n x to the power minus n 1 by 2 dx. So if we compute this integral like from 0 to like 1 to t, let's say, so that is 2 into root t minus 1. So in this case it will be 2 into root n plus 1 minus 1 is less than or equal to summation k is equals to 1 to n 1 by square root of k is less than or equal to 1 by 2 into root n minus 1. So if we subtract root n minus 1 on both sides, so we'll be getting 2 into square root of n plus 1 minus root n is always less than or equal to the summation minus square root minus 2 root n minus 1, which is nothing but our xn, and that is less than or equal to 1. So we can clearly see that left hand side is positive and it tends to 0 as n tends to infinity. So in particular the sequence is bounded below by a positive quantity and bounded above by 1. So therefore like xn is bounded, and because like this xn is monotonically decreasing and bounded below, so it also converges to some finite limit. So therefore the sequence also converges. So both B and D are correct answers.